Hello friends, welcome to Dennis Simplifies. In this video, we are going to be printing Armstrong numbers in C++. I bet you are yet to find out what Armstrong numbers are. The algorithm first and then the code. So, let's simplify. Some 3-digit numbers in the range 100 to 999 inclusive have the characteristic that the sum of the cubes of the individual digits in a number equals to the number itself. A typical example of such a number is 153. 1 cube plus 5 cube plus 3 cube gives us 153. You are required to write down a computer solution for displaying all 3-digit numbers that have the above characteristics. Your computer solution should be written such that no inputs are to be entered from the keyboard. To the algorithm, since you are going to be moving from 100 to 999 inclusive, you are going to set a for loop that starts from 100 to 999, and we keep increasing it by 1 till we get to 999. So we say for I equals 100 to 999. Now we say new I equals I. That is, I'm going to set the value of I, which is currently 100, to new I. I'm going to save a copy of it in new I. I'll explain why we are doing this as we go along. Now I create an empty variable called sum, which is going to store the sum of the individual digits in the number. Then from there, this sum is also very important. The position of it is very important. As you go along, you know why this is. Now I'm going to set a while loop. Now in this while loop, I say while I is not 0. That is while 100 is not 0. The last digit in 100 equals I modulus 10. I want to take the last digit in 100, then raise the last digit in 100 to the power of 3, then add it to sum. Then after raising it to sum, that is sum plus equals power last digit 3. After raising the last digit to 3, I'm going to take that last digit away. So I divided equals 10. Take that last digit away and then n while. Now if I take the last digit of 100 away, I'm going to get 10. Since 10 is still not 0, I can enter this while loop again. Now when I enter the while loop, the last digit in 10 is going to be 0. Now I'm going to raise the 0 to the power 3 and then add it to sum. After that, I'm going to take that 0 2 away and then n while. And the condition is that I is not 0. Since 1 is not 0, I can enter the loop again, and the last digit in 1 is still 1. So I'm going to raise 1 to the power of 3 and then add it to sum. Now after adding it to sum, I'm going to take this 1 away. Now when I take the 1 away, there will be no digit left. I'm going to get 0. Now since I is now 0, I can't enter this loop no more. So sum is going to contain the sum of the digits in 100, which is 1. So if the sum in the digits in 100 is equal to new I, then I should print that new I is an Armstrong number. Now you see the reason why I made a copy of I in new I. Because at the end of this while loop, I is going to be 0. So I save a copy of it so that I can compare the sum in the digits to the new I, which is the original I 100. So if the sum is equal to 100, then that new I is an Armstrong number. Then NF. Now before I end the for, as I said, I was 0 at the end of the while loop. But to go back to the top of the for loop, that is to increase from 100 to 101, I currently is 0. But to move from 100 to 101, I must be 100 again so that I can move from 100 to 101 to 102. So I'm going to say I equals new I. I should bring back the copy of I to it. So I'm giving I its original value, which is new I. So I say I equals new I n4. Now when I come back to the top of the loop, I can increase from 100 to 101 because I has gotten its original value back again after it goes reduced to 0. So now I can increase from I to 101. Then I'll come back, I'll take a copy of the 101 and save it in new I. Then remember, sum is 1. But then before I enter this loop, I want to make the sum empty so that I can calculate for the sum of the individual digits in 101. Remember that sum already contains the sum of the digits in 100. So before I can calculate the sum of the individual digits in 101, I must make sum empty before I enter the while loop to calculate the sum of the individual digits in 101. That is why the sum is equal to 0 over here. And this position is very important. You have to first empty it before you calculate for the sum of the digits in the next number. Alright friends, so this is going to go on until we get to 999. Now let's convert our algorithm to code in C++. So in the int main function, before the int main function, I included the cmath library because we are using the power function. Then in the int main function, I declared I, last digit, new I, and sum to be integers. Then I ran a for loop from 100 to 999, and step 1, increase it by 1. Then I save a copy of the I in new I. And then I create an empty variable sum which will contain nothing. Then the while loop which at the end is going to have the sum of the digits in the number I. Then after that, I save a copy. I check if the sum of the digits in the number is equal to new I. If it is, then it is an Armstrong number. Then I come back to I and save a copy that I already saved in new I in the I before I end the for loop, and then move to the top and then increase that I by 1. Then I end my code, the system pulse is greater than 0, and then return 0. Now let's run the code to see if indeed we are going to get the Armstrong numbers. So on pressing enter, we can see that 153 is an Armstrong number, 370, 371, and 407 are all Armstrong numbers. When you punch it on your calculator using 1 plus 5 plus 3 you'll be getting the same answers as we have here. Alright friends, so that's it for this video with Armstrong numbers. I hope you learned something. Don't forget to like and subscribe. See you in the next video. Till then, apatia.